Welcome to our second SERC Talk of 2023 and of our Celebrating Systems Engineering Digitalization series. Thank you all so much for taking the time to join us today, and welcome back to our familiar faces. Really looking forward to your questions, comments, insights. Please feel free to utilize the chat for that. It's my pleasure and privilege to introduce Dr. Heidi Davidz. Dr. Heidi Davidz is an engineering fellow at the Intelligent Systems Engineering team at ManTech International Corporation, where she works to modernize SE practices using model-based and computational technologies. The current emphasis is on process, methods, and governance to span agile to waterfall system development. And with that, just to preserve time, I'll turn it over to you, Dr. Davidz.
All right, thank you so much for the introduction, Mimi. And for those participating online, thank you so much for joining today. Please do ask your questions in the Q&A feature, and we'll get to those questions at the end of the session. So for today, I'm really focusing on how model governance can aid digital engineering execution. So in today's talk, I'll first go over an overview of model governance and also talk about why it's so important. And then I'll focus on three key points. First, know what you have. Second, know why you have it. And third, know how it's controlled. So these seem like very basic, simple principles, but when you're in the midst of a program's execution using digital engineering, things can be much more challenging than you may think. So again, the three things that I'd like you to remember is to know what you have, know why you have it, and know how it's controlled. Next slide, please. So model governance is within the broader topic of data governance. Sometimes when people talk data governance, they're really talking more at the enterprise level. So why we've really chosen to hone in on model governance specifically is because as people start working in a more model-based way, governance is very important, and sometimes the importance of that gets overlooked. So that's why we're really talking model governance specifically. So this is the working definition that we're using. It's documented decisions, rights, and accountabilities for model-related processes executed according to an agreed-upon set of rules which describe who can take what actions with what models, when, under what circumstances, using what methods. So a key thing you're going after here is transparency. So all those working in the digital engineering ecosystem can understand how the various assets are being controlled. You want that to be transparent to enhance trust in the artifacts that are generated. You also want there to be a collaborative nature to what you design for governance. Should be an agreed upon set of rules, not just something that comes from higher up that people may or may not agree to use. And also it needs to be measurable. So it's not enough just to establish a set of rules, establish the governance that you'd like to have, but you do want to check to make sure that people are following those rules. So there should be some measuring and follow-up also in model governance. And as you'll see listed there at the bottom, I have some of the references that I'm using throughout the presentation. There's a reference slide at the end. If you'd like to read more about some of these concepts for yourself, those references are provided. Next slide, please. So the United States Department of Defense and its digital engineering strategy define the following. That digital engineering is an integrated digital approach that uses authoritative sources of system data and models as a continuum across disciplines to support lifecycle activities from concept through disposal. So the first challenge there is just to use models, to get information from document-based format into model-based format. So that challenge is a lot in itself, just being able to use models. Next, please. So once you have that information in model-based format, the next challenge is to link that so that you've got this integrated continuum. You're linking your manufacturing models to your design models, to your system models, etc. So how people link models across different domains becomes a challenge. Next. And once you have that in place, there's the issue of distributed data management. So each of the historical domains have ways that they have controlled their information over time. So in manufacturing, there's manufacturing execution systems. For more at the enterprise level, there's enterprise resource planning. You have native versioning available in your tools. For physics-based simulations, you have simulation process data management, SPDM. You may be tracking different variants, which case you have a variant management system going on. In the software community, that historically application lifecycle management, ALM, has been important. And in mechanical design, product lifecycle management, PLM, has been important. It's important to understand, though, that it's not one thing. Different disciplines have different ways that they've been controlling their data and assets and models. So it's important to understand that it can't be just one thing. Just ALM, just PLM isn't enough. Then when you consider this across an acquisition chain, you have many different organizations who've chosen to fill these challenges in different ways. There's different ways that they've transferred their information from document-based to model-based format, different ways that they've linked those domains together across the digital thread, and different ways that they are doing distributed data management and linking their ALM, PLM system, etc. So when you aggregate that across the acquisition supply chain, it becomes very complicated. Next, please. So the reality is that governance across the digital thread must address a set of data management tools to ensure quality for decision making. Next. This is why governance is so important. It's not just one system. It's really understanding how all these very important mechanisms for control play together to establish control for the full digital engineering ecosystem. Next slide. So why do you need governance? What you're trying to do is organize the digital engineering ecosystem to execute efficiently and reduce the cost of confusion, churn, and rework. So first, there's scope. So what models and data are even in the program DE ecosystem? Understanding what's there is extremely important. So understanding the scope of what you're trying to control. Next are the rules. So who needs to interact with those models and data? As we try to use models in more domains, people who have been in roles that didn't necessarily need to use models in the past may need to use models now. So those roles, the content of those rules may change, and the training for those rules may change as well. Then there's purpose. We're not just modeling to produce a model. We're not just doing a digital thread to have a digital thread or to have a digital twin. We're really trying to help accomplish a mission in a better way. So all these models, data are for some type of purpose, and understanding that is very important. So why are the models and data needed for the mission? And then there's process. What actions happen when? Particularly as you start ingesting model-based artifacts from your contractors, it became very confusing on who needs to evaluate what, in what format, what point in time. As you start to link together different domain models, the authority becomes somewhat ambiguous in some cases. So really having an explicit process becomes very important. And then there's the location. So where do the models and data reside in the infrastructure, whether it's across classification levels or maybe other parts of your infrastructure that may be more cyber vulnerable? You really want to understand which models for which purpose live in which areas. Next slide, please. So again, building off the data governance literature, there's a distinct difference between governance and management. So some will argue that it's really just all model management. We can just put it in the category of model management. But if we look at what's going on in data governance, they really separate these. Governance is defining the right things to do. Management is making sure you do the right things. And then again, it's governance that oversees that the right things are happening. So these are handled in data governance as two sides of the same coin. That coin's increased model value and reduced risks. So model governance ensures that model management is happening. Next slide. So on a slightly different topic, I'd like to talk about solution debt in digital engineering. So in the software engineering practice, there's this idea of technical debt. So your tech debt is that implied cost of additional rework when you choose a limited solution now. So that tech debt can accrue over time in your backlog as you're planning your sprints. You can burn it down and it's actively managed. In the data governance community, they have this idea of data debt. So if you don't have the right controls in place as the data are being generated, you can incur debt. So this is the cost of cleaning up your data so that you can use it at a future point in time. So you want at the onset, before the data are created, to establish what it is that you want them to look like. So we've combined those in an earlier paper. We talked about solution debt. So solution debt is a more comprehensive view across disciplines and also across life cycles. So solution debt's more for the systems engineering space. It includes traditional software tech debt, along with data debt, programmatic debt, and some other types of debt. So in the debt literature, evaluating that debt, there are three things to take into account. One is the impact. So because you're carrying that debt, what's the impact to your solution or system? The second is the fixed cost. How much does it cost to just go fix your debt? But the third thing is really interesting. It's contagion level. So if you don't fix your debt, how much does that disturb other parts of your solution? And that, of course, can increase over time. So if we extrapolate this and think in the digital engineering space, as we start to connect our data and models across the ecosystem into this digital engineering thread, we're connecting data in a very useful way. But due to this issue of contagion for debt, we can also super spread the impact of debt. So if you have an aerothermal analyst who may be a little sloppy with their assumptions, at one point in time, that was a more localized problem. But now, if you've got your aerothermal model linked to your CAD model, linked to your cost model, you're doing these very dynamic optimizations. The debt that you're carrying can cascade through your system more quickly. So it's something that definitely is of concern. So in the data science and data governance space, it's really data governance is how you deal with debt. And so what we're saying is really, again, governance is how you deal with this solution debt. Next slide. And also in the data governance literature, they talk about the cost of data debt being used to justify data governance programs. So when you examine the cost of a data spillage event or other data events, you could quickly justify the return on investment for a data governance program. So I've included some statistics here from various resources. You can read these resources yourself. But it really emphasizes how extreme the issue is for bad data and data debt. So experience says that the cost of bad data can be 15 to 25% of revenue for most companies. IBM says that businesses lost $3 trillion per year due to bad data. And Gartner says every year, poor data quality costs organizations an average of $12.9 million. So when we think about digital engineering, we also need to think about the cost for poor data and model management across our organizations. more we can quantify that, we can justify some of the costs it takes for governance programs. Next slide. So the solution is to design, deploy, and sustain an effective data and model governance program. At ManTech, we have a model governance guide that we use. And how this is, it's model-based guidance within model work instructions. We integrate the design of the overall model governance system with the design of the digital engineering ecosystem, the D infrastructure, the governance of individual models, and the governance of composite models. We have traceability of model purpose, an opportunity to trace your technical and solution debt. There's validation, automated validation for insight on compliance. And then there's also this item of flexibility. So you want customization for flexibility and tailoring. So in different organizations, the tolerance for governance may be smaller or greater. So it's important to right-size the governance efforts for what's sustainable within that organization. Next slide. Okay, so the 4 key components of the ManTech Model Governance Guide, again, is designing that program model governance system in a purposeful way. You actually go through the systems engineering process to purposefully and systematically design how we're going to do governance. And then that also links to the design of the digital engineering ecosystem infrastructure. So this may be a completely different model that you're linking to, but the key thing here is that you actually have an architecture for your ecosystem. It's not just a Visio chart with some tools on it. There's purposeful design in your infrastructure, and that links to how you're controlling your models. Then we also have the design of the governance of the individual models. And as we saw earlier, different domains control their models in different ways. So the governance of different kinds of individual models may be different. Maybe you're using a very robust PLM system for some of your models. Maybe it's a very robust SPDM solution for other parts of your ecosystem. What you're trying to do is understand each of the models in your system and how each of those are being controlled. And then there's the design of the governance of the composite models. And how we define it is that a composite model is 2 or more individual models that are linked. So the governance of that joint composite model may be different, but certainly needs to be integrated with the governance of each of the individual models. Next slide, please. Okay, so getting back to the 3 key points that I'd like you to take away. Know what you have, know why you have it, and know how it's controlled. So first, let's talk about know what you have in more detail. Next slide. So here's a notional value stream, simplistic, just for illustration purposes. So there's some trigger. You have a series of value-adding steps that you're executing to get to some type of value delivery. And then there's a lead time between the trigger and the value delivery. So if you don't know what you have, how can that interrupt your execution? So just a couple issues are brought up here. One potential thing would be, what models do we even have on this program? It can seem like a silly question, but when there are programs that have hundreds, if not thousands of models that have evolved over a very long period of time, getting control of what models are even out there can be a challenge. And understanding what models use which tools and applications and who the point of contact is, that can be an issue. So when it comes to governance, even a model catalog in some organizations can be value added to help with flow and execution. Another issue might be metadata. So you want to think about the model metadata that will be delivered in the contract before that contract is in place. So one issue might be, why did we not require that model metadata in the contract? You don't want to figure that out 3 steps into your value stream execution. You need to think about your metadata up front, what you might be needing particularly if you have model-based deliverables. It's not enough to just have the contractor deliver you a SysML model. You need to think about what set of metadata you want to go along with that, whether it's 5 pieces of metadata, 10 pieces of metadata, or 150 pieces of metadata that go along with that deliverable. Next slide, please. Okay, so know what you have. Here are some examples. This is not an exhaustive list, but see, these are some of the things you may want to consider to really understand what it is that you have. You need to know what models you have, what other data types that you have, what the metadata are that are affiliated with those models and data, the connection between those models and any standards that have been put in place. Some of the standards call out the metadata that you might need. Any requirements that you have for the models and how you're verifying those models. There's, of course, the assumptions, the risks that go with the models. And then, again, we're trying to not just model for modeling's sake, because we really like to do SysML modeling. We're trying to model for a purpose. You're trying to inform a decision to execute for some type of mission. So keeping that in mind is very important. In one of the standards, they really talk about the criticality of the decision that the model is informing. And as they assess different models, they do a triage, and things that are highly critical have more metadata required than other types of models. There's model location, as we talked about, where it lives in your infrastructure. The tools and applications that you're using, that's another thing of know what you have. There's contractual requirements, the timing delivery. We have some programs that are getting model-based deliverables every 2 weeks. So the pace there is a very important factor when you're assessing what it is that you have. And then there are the resources for the modeling, workforce issues, and also if you have people who are ingesting model-based deliverables that aren't used to doing that, there's additional training there. So really understanding those resources becomes important. And then knowing what training that you have in place. So again, it seems simple, just know what you have, but again, this isn't an exhaustive list. Okay, it looks like we have a question online, but I think we're waiting till the end. So please, Andre, if you could put your question in the Q&A, we'll answer it at the end. Okay, next slide, please. So there's an evolving set of standards that inform the specific approach. So there's MOSEC, the modeling and simulation information in a collaborative systems engineering context. As more tools use MOSEC, this makes the job easier for controlling some of this governance. There's a NASA standard 7009A, which is a standard for models and simulations, and it has a very extensive list of how you control the model through the full life cycle of that model. So even if you're not working on a NASA program, that may be a resource that you want to look at as you decide which metadata you're trying to control on your program. There's an OMG effort for model-based acquisition. And as this user group builds over time, they'll come up with more standards that will be very insightful, reference architectures, et cetera. So you can use these standards to inform your approach and which metadata you're trying to track. Different standards apply to different programs, and the tools and applications are implementing different standards at different pace. So that's something to stay aware of as you're considering model governance. And again, this is a space that's continuing to evolve, so keep an eye on it. So within the ManTech environment in our model governance guide, you can see a snapshot there. And as I said, we've got the 4 key pieces where we're designing that BB model governance system. We're tracing what our infrastructure looks like. We're designing the governance of the individual models, designing the governance of the composite models. And as we design this governance, we're trying to go through a systems engineering approach so we understand why things are in place. So when it comes to knowing what you have, there's placeholders for that information so that you can keep things organized to help your execution of digital engineering on programs. So depending on which program you're using, you're supporting, you may use different sets of metadata. So you can add that metadata and the information of interest to the model governance plan. And so there are a couple of snapshots here. These are just simple ones where you have name, documentation, assumptions, risks, but that list may be 5 pieces long, it may be 10 pieces long, it may be 150 things that you're tracking for your models that are highly critical. So in the NASA standard 7009A, some people will use a spreadsheet to track those pieces of metadata. So something like a model governance guide provides you with a more robust approach to be able to handle each of those models, the metadata that are associated with them over the course of the life cycle of the model. Next slide, please. And here, in understanding what it is that you have, is a snapshot of your digital engineering ecosystem infrastructure. So you're trying to understand what it is that you've got in your D and why you have it also, and then how that relates to your models. So again, hopefully your tool list isn't just a PowerPoint or Visio diagram that has a list of tools. Trying to understand the logic behind each of the tools, go through a full architecture process, understand who your stakeholders are, why you even have that tool, what the purpose is, and then what it is that you're actually using for your tool or application. And then once you've got that in place, you're trying to link that to the different models that you're using across your digital engineering ecosystem. So include the infrastructure details and the relationships to the models. Next slide. So moving on to the next point. Know what you have, know why you have it, know how it's controlled. So next, know why you have it. Next slide. So here again is that notional value stream where you're moving from trigger to value delivery and a series of value adding steps. If you don't know what you have, how can that interrupt the flow? So one thing is maybe you have been doing an excellent job of model-based systems engineering and you've saved money on the program, but you have engineers that are doing more modeling than needed and they're using up that savings. So again, what you're trying to control is not just what's being modeled, but the extent to which it's being modeled. So if a 3 degree of freedom model is all that the program really needs, your engineers aren't off doing a 6 degree of freedom model because they really like to do modeling and they really wanted to do that. You're trying to control not just the model artifacts, but the modeling efforts as well to help with your digital engineering execution. Another potential issue that we've heard is why are these seed rules being provided when they're not even needed? So this came from a government customer. They were getting models from a customer advocate that they didn't even know why they were getting some of these seed rules. They just kept being provided. They weren't really being used. And so you can understand how that interrupts efficient execution. So know why it is that you have what you have when it comes to model deliveries. Next slide. So one way that we handle this in the ManTech Model Governance Guide is to understand the model objective. So if you have a specific model, here we'll consider it Model A, and that model is to model an aerothermal environment. Maybe the mechanical engineer is interested in the aerothermal environment at flange 1, 2, 3. And your chief engineer, they're interested in whether the mechanical design of flange 1, 2, 3 is sufficient. And your aerothermal department manager, they just want to make sure that the standard work is being followed. So it helps the modeler of Model A to understand what are the questions that the model needs to address, What's even the objective of that model? It helps inform the modeling activity. So you want to have this scope and traceability for the models to make sure that you're really addressing stakeholder needs. And since you've got this in model-based format, it's easy to pull up analytics and various views to really understand that. So if you've got a model A that you're comparing to a model B, you can compare the different assumptions that are being used on one versus the other. You can track the documentation, the risks, how it's traced to standards, which use cases it's fulfilling, what questions are being answered, what requirements are being fulfilled, and then where it lives in your ecosystem. So this is a mechanism to really understand model purpose. So when it comes to composite models, you're also interested in why you have what you have. So for composite models, again, composite models are where you have two or more individual models that are linked together. You still need to understand the stakeholders, list the questions that you're trying to answer with that joint model, and then populate descriptions, come up with the metadata for that joint set. So you define the composite model characteristics to track the linked model needs. And sometimes this can be somewhat different. So if you had that aerothermal model and it's linked to your CAD model, your cost model, and maybe your systems model, the purpose of that combination may be an optimization, where the purpose of just the aerothermal model is slightly different. So you really want to consider the governance of each of those in different ways. And particularly for composite models, you may be going across different heritage data governance systems, data management systems. Maybe it's a PLM plus an ALM plus a native tool that's being used to control the composite model. So that's something that you want to understand. Next slide. So next is knowing how it's controlled. So how are the objects that you're trying to control within your digital engineering ecosystem, how are each being controlled? Next slide. Again, here's our notional value stream, moving from trigger to value delivery in a series of value adding steps. And if you don't know how things are controlled, here are some potential issues. One issue is understanding what's controlled in a PLM system versus an ALM system versus a native tool. There's also what is controlled for work in progress versus what is controlled at a baseline. So some perspectives are, let's just put everything in PLM, or really we just control it through ALM. But particularly as you're working through different contractors who have done things and controlled information in different ways, you really want to understand how everything together is being controlled. And if there's chaos or confusion or ambiguity here, it can interrupt your execution and delay your flow. Another issue is for a specific composite model series, say composite model series A. What are the new roles for individual model changes? So going back to your aerothermal model, if you just have an aerothermal designer, maybe they control their model in a specific way, but now that that is being published to a digital thread and linked to other models, how that model is controlled may be different. So again, if there's ambiguity there, if there's uncertainty, if there's not sure what the roles and responsibilities are, that can delay your execution. So as we're trying to get weapon systems out faster, more efficiently, with higher level of fidelity, we need to really examine our execution and clean up some of our processes to make sure we understand these things. Next slide. So key here is deploying governance. You want to design, deploy, and sustain an effective data and model governance program. And sustain is a key aspect here. So it's not just enough to come up with a very elaborate system that people may or may not comply with. Being able to sustain that governance is very important. Another piece here to consider are the cultural implications. So before you had different individual organizations and what they were feeding back and forth to each other were documents. But now that we're flowing model-based content back and forth or joining it in an integrated digital thread, you may have one organization that's used to very rigorous tracking. Maybe they have 150 pieces of metadata for their critical models. You're linking that to an organization that may only be used to tracking point of contact and where it lives. So it's very different as you're trying to integrate across this model-based acquisition chain. You're joining very different cultures when it comes to governance. So again, if you're trying to design, deploy, and sustain an effective data and model governance program, you need to consider those cultures and how they may integrate. And the long-term goal here is that it's just institutionalized. It's in everyday operations, so it's not something that's perceived as special or new. It's just how people do business in the design. So you need to consider the business model, the content that you're governing, the degree of federation, and the methods that are being used. And as I was saying, the need applies across the data and model supply chain. So it's not enough just to govern at the government level or at the prime level, particularly as you're ingesting data and models from lower levels in the supply chain. You need to understand how those model-based assets have been governed over their lifetime as well. Next slide. So here's some more snapshots of activity diagrams in the ManTech Model Governance Guide. You're trying to purposely design your governance system. So what we've got activity diagrams with some example model artifacts that you may populate as you go through. So if you're defining your use cases and populating the diagram with stakeholder concerns, questions, and models, there's some example artifacts that you're populating. Same with model descriptions. You're populating the metadata as you go through. So we're trying through our governance guide to provide instructions at the point of need to make this easier. Next slide. So updates have added automation. So automation and ontologies reduce the amount of manual effort. So if you've got these different models that you're trying to link together in one model governance plan, there's a widget that we have that imports the governance metadata. It scrapes constituent models across an ecosystem to report the governance information. And then automating the ingestion of the governance data reduces the chance for error. So the more automated, the better. The more this just works in the background, the easier it is to sustain. For this particular widget, where the governance metadata are lacking, there's a user interface that guides the input of the missing information. So automation helps maintain this catalog of model information into the governance plan. Certainly model catalogs aren't a new concept, but what is new, some of the automation that's available now to make this happen in an easier, more efficient manner. Next slide, please. So here's some snapshots from the widget. It's under our plugins. You run model governance. You can see there's a GUI that pops up if you're missing some of the required information. And again, this is you define the metadata that you want, depending on which standards you're using and what's in line and appropriate for the context of your program. And then you can adjust this. The widget then pops up a GUI for any information that's missing from the metadata, and you can enter that in. So this was originally developed to scrape Cameo SysML models and also CSV files, but the concept is that we will scrape models and data connected to an ontology-based digital thread. So it's just a proof of concept that we've done in Cameo and with CSV, but can see how this could be extrapolated to scrape the models across the thread. Next slide. So as we have more incorporation and utilization of semantic integration, this will aid governance. So if you're utilizing a semantic ontology first, hub and spoke digital thread integration platform, that can help with your model governance purposes. So again, we're not just modeling for modeling's sake. You're modeling, you're connecting that information across that integrated thread to be able to do the analytics to really inform the program. So organizing governance using ontologies produces an agnostic approach, allowing customers to plug and play best-in-class tools regardless of what current tools they have in place. So it's not like you're taking all the information, putting it in one PLM system. You know, if you have the semantic ontology-based approach, you can plug and play and maintain that governance across your integrated thread. This also helps capture contextual information that helps with appropriate model reuse. And then you can also have validation suites across that integrated semantic thread to ensure accuracy, completeness, help with change impact analysis, etc. This also helps with dashboard views of model governance compliance status to aid program execution. Next slide. So again, to summarize, there are 3 key points I'd like you to take away. When it comes to model governance, know what you have, know why you have it, and know how it's controlled. Next slide. Here's a list of some of the references that were used throughout the presentation if you would like to learn more. Next slide. And if you'd like additional information, please reach out to myself, to Douglas Oriana, or Ms. Kimberly Nunn of ManTech. All right, that's the end of the formal presentation. We can move to the question and answer period.
Yeah, thank you, Dr. Davidz, for your wonderful presentation. Before we jump into the Q&A and let everyone kind of form their questions, feel free to keep on putting them in the chat. Just a couple future events to note. We have the ERIC and DAU debarment webinars coming up next Tuesday, September 12th, and Wednesday, October 4th. The slides are available on the website at the link in the chat, so feel free to click on them to access the registration links. Similarly, for the AI for SE and SE for AI 2023 workshops, this is an event that's an annual event that's been expanded to have a virtual follow-on open workshop that allows for non-US citizens to participate as well. The live in-person event is on September 27th and 28th. The seating is limited and reaching very close to capacity, so if you're hesitating on registering, please do so before space runs out. And then our annual event, the highlight of our year, is reviewing all the SERC research, as well as allowing an open forum for our SERC doctoral students to present their work. That'll be taking place on Tuesday, November 14th and Wednesday, November 15th. So stay tuned, registration should be opening up soon for that event. But I will turn it back to the Q&A. It looks like we have quite a few questions that came in. And thank you to Kim and Doug already chiming in with some answers. Just to allow us to pose it back into the room. Dr. Davidz, Phil Zimmerman asked, do you equate governance with curation? And Kim, Doug, Heidi, feel free to jump in with your responses.
So I think from the definitions that we're using for governance, curation is part of this bigger effort. So with governance, you're also controlling the modeling effort as it happens before you're trying to curate those assets. So you're trying to control whether the engineer goes to 6 degrees of freedom or 3 degrees of freedom for them to really understand the objective of why they're doing the modeling. So I think curation definitely is an important point, but I think we're really trying to understand the full life cycle and also influence the active creation of those model artifacts as well. And Kim and Doug, please feel free to chime in. Okay, next question.
So this is Tom, Heidi. I have a follow-up on that governance question, which is the human side of governance. So how do you enforce governance onto engineers who would like to model the problems on their own and not be handed a reused model?
So I think that depends on the different organizations, but usually engineers need a charge code, right? So you have so many hours. This is the time box. This is the resource box for this modeling effort. And also, as you're doing the peer review of the modeling effort, if it's very apparent, and we talked about transparency at the beginning of the presentation of what the model objective is, that becomes easier to evaluate during peer review. So you can see like, whoa, this has really gone off the rails. You've gone to way too much detail for the amount of budget that we have for this program. I think also as you're maybe doing more iterative execution and iterative review of model-based artifacts, it can help with that. So people aren't completely off the rails before you see that the modeling effort has gotten out of control.
Thank you. So this is maybe a related question from Jeff Kerr at Virginia Tech. How does ManTech harden the data governance system against the somewhat fragile integration of various digital engineering tools as they're being updated?
So ManTech historically has been an IT cyber company. So cybersecurity is taken very seriously. We work behind zero trust walls. And so some of those cyber practices are also in place with the different assets that we're developing within intelligent systems engineering.
Okay. There were a couple of questions on metadata. So different people and different programs obviously have, based on their experience and understanding, have different definitions of metadata. And so do you have experience from ManTech that drives what your definition of metadata would be on programs? And also following that, do you know of any evolving metadata standards that should be followed?
Right. So within ManTech, we're a services provider in many cases. And so we need to use what it is on the program and what their standards are that they are working to. So metadata to me, and through this presentation, is the auxiliary information that accompanies the model. So different standards define that more precisely in different ways. So like the MOSEC standard, there's a specific set of metadata that they recommend go with different models and simulations. If you go to the NASA standard 7009A, there's a series of data that really track with that model and simulation through its entire lifetime. So in the model governance guide that we have, we didn't choose to use all that, all those specific categories across 7009A, because again, you want something that's sustainable. So for organizations that you have engineers that don't want people in their business, asking them for 5 pieces of metadata may be culturally revolting. But other parts in other organizations across the acquisition chain, people are used to providing a lot of extra data to supplement their modeling efforts. So they've got that contextual information. So in the governance guide that we have a recommended set, but that certainly can expand or contract based on the standards to which the program needs to comply. And also what the program's trying to do. So depending on how much reuse they have, if they're part of a model portfolio management system, there may be specific pieces of data they want to collect on each model so that it helps with their future reuse. So it's context dependent.
Also, one thing that we do in order to enforce some of that is our ecosystem is built to provide non-persistence. So they have to use some of our CM information systems that require them to enter that metadata that we require in that ecosystem. So we are designing the ecosystem that these things live in to actually implement some of that governance as well. So it's not just open for interpretation of how people are using it, where they can store it. We're actually forcing folks to use specific storage systems, and because of the way they're using it, we're implementing policies on those storage systems and how they enter that data into it.
Thank you. And in response to Rick Gray's question about is the SERC aware of evolving metadata standards, one thing I think in the Defense Department in particular, there's a lot of standards that are around issues or concerns like airworthiness or reliability and maintainability that imply metadata standards. So I think over time, the government's going to have to be very diligent about defining the metadata that they want to see in their program. Heidi, from your experience, are you seeing this type of information from government sponsors?
Right. And I think some of that's evolving based on the government sponsors' needs. So, one program, they're getting model-based deliverables, some of those coming in every 2 weeks, and there's hundreds of model-based deliverables. There are things that are of higher priority to them than maybe some of the standards that are in the evolving bodies. So again, we really want to focus on execution, want to focus on the needs of the program.
Thank you. Shoma, you wrote ISO IEC 42020-2019 software systems and enterprise architecture process. It defines the relationship between architecture, governance, and management. Is there anybody working on turning ManTech's process into some kind of industry standard?
No, we haven't. Don't have current efforts to turn this into a standard. It's more been developed for internal processes as part of our systems engineering process development and best practices internally. We've offered it up to programs for their use, but not at this time. We have not been pursuing this as a standard.
Dr. Doherty asks, after a product has been delivered and you're in the maintenance and upgrade cycle, how should you manage the models and tools? Do you upgrade the tools and continue to revalidate the upgraded tools against the then current product baseline? Or do you retain the capability to roll back your modeling environment as needed?
So that's a challenging question as you get into maintenance, because a lot of these tools continue to evolve over time. So some of the evolving low-tar standards become really important, that long-term archival and retrievement and how you want to design that. And one of the key things with digital engineering, people are say, well, you need to use digital engineering, you need this to be model-based, but it's got to be areas of opportunity where there's a return on investment for some of those efforts. So it may not make sense to go back something that's just on physical documents, physical drawings. They're not even maybe even in a CAD system. It may not make sense to do the forensics to make that into model-based standard with contemporary tools, and you want to just use it. And maybe it's at the next upgrade that you're doing some of that work to bring it to the latest standard and to the latest tools. But yes, that's definitely something that's of concern, is low tar and how you handle that on the program. But again, as you're tracking your solution debt, your technical debt, over the course of the program with this holistic governance system, those are aspects that you want full visibility to understand where there may be some vulnerabilities.
Yeah, the other aspect of LOTAR is that it's not just the modeling and the tools, it's actually the computing infrastructure itself, right? As the IT goes to containerizations, that's the technology of today. 10 years from now, it's going to be something else. So is the containerizations that you built today to be able to rerun models or simulation, is that going to be, how is that going to differ in a new computing infrastructure, right? And a drift of decimal points can mean a huge difference in answer depending on the model and the simulation. So it is, I think, something of topic. We haven't really looked into the infrastructure piece, but it is something that we're aware of and I've been talking to vendors about.
Thanks, Doug.
Thank you. DAMA has a data management knowledge system guide. Are you familiar with that? Did you use it in your design? And how might it help with governance metadata?
No, we did not consider that. So I definitely would be interested in learning more about it.
David Gorsuch said, I love the slide on ROI for data governance, but the facts came from industry reports. probably provided the references behind those estimates. And I think there's been a couple comments on there. Has anybody studied the DoD services and what those numbers might be for good bad data or good bad data governance on the DoD side?
I think there's definitely opportunity there. And I think some of that's unmeasured costs too. So the costs of people going out to find the latest piece of information, is this the latest model? Is this not the latest model? You track some of that when you're doing lean training and trying to understand flow. But I think there's definitely opportunity in this area to really understand how this relates to digital engineering, and that churn by not having good governance in place, and people don't know where data are coming from, where these models are coming from, why people even have these models. There's a lot of unseen costs that I think it would be very shocking to see some of the numbers and how much it could help with the execution of some of our weapon systems. And these are just statistics that are pulled from those references. So and some of them arguably, they're not the most robust assumptions that have been made, but the references are there for your own evaluation.
I'll use that to put in a plug for the digital engineering measurement working group that NCOSI and the SERC and all have been doing. This issue of ROI, of digitalization of engineering in general, has traditionally not been measured well, and we're currently working a version 2 of that framework. So we would be interested in people supporting that, particularly when you start looking at underlying data as opposed to things that are model elements or other processes like that. So Phil Zimmerman asks, is there any formal articulation of a governance hierarchy or what this encompasses in your organization, I guess, or in your guide? We've come across data management model and modeling, control, and curation in many different forms today.
So within our model governance guide, we've defined much of this based on the data governance literature. So the citations that we use are listed there within our governance guide. But there's a huge effort in the data governance community it's a very active community, of course, with the importance of AI, ML, data robustness, et cetera. There's much to be learned from the data governance community to bring over to the execution of systems engineering.
Ben Cassell asks, how does your requirements for mandatory metadata related to 649? I'm not sure what that means, but.
Right, and so there's a series of standards that people have, and so for different programs, people think different pieces of standards are necessary or on contract. So again, I think it depends on which standard your program has enacted and is living by.
And maybe this can be the last question here. Elgin Ireworth, how critical is setting up the governance up front to support federated models across major acquisition programs?
Yes, absolutely. So really you want governance in place from the beginning when you're even proposing your solution. So it's just like data governance, the more data that are created before you governance in place, the higher your data debt is, the higher your cleanup will be, your cleanup costs later. So it's the same with model governance. You're trying to get your ecosystem under control before the models and the data get out of control. So as soon as possible.
Thank you. Thank you, Heidi. Amy, I think at this point in time, we're after the hour. We probably should wrap up the session.
Thank you, everyone.
Over to you.
Appreciate that. Thank you, everyone, for joining, for the great input, comments, questions. We kind of had a feeling we would run out of time and still have questions. So please utilize the link to the LinkedIn event page so that you can connect amongst yourselves as well as continue the conversation. Thank you again, Dr. Davidz, Kim, and Doug for presenting today. And we'll see you for the next talk. So thanks again for joining. See you next time.
Thank you all.
Thank you.